Hello, my name is Reef, Borja. This is my final project where I modeled my Onewheel, an electric self-balancing vehicle that operates on a single wheel, hence the name. Here's an exploded view of the assembly showing all of the parts used. Taking a closer look at the frame, we see that it is nearly identical on both sides. When creating this part, I made a drawing for half of it and reflected the rest over a center line to save time. The wheel mount was made through the creation of multiple new planes and required me to deconstruct my Onewheel to get accurate dimensions so I'd face less problems when mounting the wheel. Most of the aspects were created by using extruded base, revolved base for the center of the wheel mount, extruded cuts, and like mentioned before, mirror. Now with the fender, it also required making multiple planes, revolving a base, and boundary cuts, which I learned more about on YouTube. The hardest challenge with this part was creating the concave sides that led to where the fender would be mounted. I made it without the cut at first and then took out a portion with the boundary and swept cut to achieve that look. With the wooden foot pads, the fact they had concavity made this a harder challenge. These foot pads required a lot of trial and error with different cuts and even drawing multiple cylinders with gradual height differences to achieve the slope closer to the center. The kinematics of my design is the movement of the wheel through a motor. For the simulation, I emulated myself riding 20 miles per hour towards a rock while on a trail ride, failing and having the fender crash into this rock. The average force in this collision would be 131.827 newtons, which is the effect shown here. Thank you for watching this video. I had lots of enjoyment and learned immensely from this project. Here are some last looks at my Onewheel.